everyone, I'm Wilson and I'm here to present regarding our project, Progressive Advancement of Transportation Networks through the Integration of Vehicular Onboard Technologies with Online Platforms, or ARANGKADATA for short. Okay, so the goals for this talk are simple: to introduce the project, to give you a high-level overview, to show some results, and to share some insights and recommendations. Okay, so for an introduction, in 2017, we all know that the DOTR launched the PUV modernization program. Okay, basically, the modernization program required our transport service providers to shift to newer vehicles. So from the one on the left, the one on the right, okay? From one that uses very dilapidated engines to ones that are Euro 4 engines. From ones that are air cooled to something to vehicles that are air conditioned. Okay. However, the changes are not all physical. The new regulations also required our new vehicles to carry electronic devices or onboard technologies such as GPS receivers, CCTV, dashboard cameras, automatic fare collection systems, and free Wi-Fi. Okay? Now, the central thesis of the project is this. These onboard technologies, which are required to be carried by the vehicles, they would only be truly useful and they would only achieve their true potential if they are supported by proper, well-designed platforms. As such, our project will design, build, and build, and test platforms that will realize the potential of onboard technologies is stated in the regulations. We are also going to take into account human factors as well as likely technological developments in the coming years. So in a nutshell, we have something like this. These are the devices mentioned earlier. This is the GPS receiver, CCTV, automated fare collection systems. They will be producing data. There are systems here that will take in those data, and these systems will produce information, insights, and therefore value. Now, we have our project as several subcomponents. The first subcomponent that I will be discussing takes in the input from GPS receivers and the CCTV. Okay, and that system is the waypoint system. Basically, what the waypoint system does is that it takes in GPS data and CCTV data and synthesizes them. Okay, so this is a screenshot from the system. This is actually an annotation system. So basically, we have here on the left video clips, and we have human annotators, humans for now, that actually tell us how many people or passengers are seen in the video clip. Eventually, this leads to this visualization, which tells us at certain locations how many people are inside the vehicle, as well as how many COVID regulations violations were seen. Okay, so because if to contextualize, this project began right at the middle of the pandemic. Okay, so here's another screenshot of a CCTV feed, CCTV video. Okay, and then here's GPS data. Here's a graph indicating how many passengers are inside the vehicle at any one time. Now, this data, the number of passengers, the occupancy data, this is important because in the long run, it helps us with our route planning. Okay. Now, for our next project, for the next project subcomponent, the system takes in simply GPS data, and from that it produces information, insights, and value. So basically, we have in diagram we have the vehicles here. They have GPS devices. The GPS devices are consistently depositing their location data. We are storing them in our database. This is already being done by the LTFRB. Okay. Now, what is different in our system is that we propose that this archiving system be made open securely to other developers so that we could develop applications that could take advantage of the data being deposited. Okay, so of course the proof of the pudding is in the eating. So we actually created this system, and of this system we created sample applications of several of which I'm going to show here. The first application that we created from this open system is this ETA application, which basically tells the passenger how long he or she has to wait before the vehicle arrives. Okay. Another one is Jeeps. Okay. This application for its part tells us performance metrics of our public utility vehicles. This, as you could imagine, is helpful for the service contracting program. Okay. Here's another screenshot of the said application. Again, so our systems take in data in this for the projects that we saw from GPS and from CCTV. We don't have any data from the automatic fare collection systems because these things are not deployed yet, not in most public utility vehicles anyway. So why is this important? This is important because of three things. First, anecdotally, operators really do not use these devices. Okay? So for many of them, they see these devices as unnecessary burdens. They would not install or buy these things if we did not require them. Okay. Second, modern PUVs are expensive and are getting even more expensive. We know this. This is quite a recent issue. Um, what is important here is that the information, insights, and value that was generated by the systems, in a large way, this can help defray or even justify the additional costs. So, what stands in our way? What are the problems? Firstly, we have the substandard equipment. So, for example, we have this memorandum circular which requires that GPS devices must send data to the server at least every 10 seconds. Okay, however, we saw quite a number of GPS service provider outputs, and we never saw this. It's always slower than 10 seconds. And this is important because the way the story that your data tells you is largely dictated by this reporting rate. This is what the path looks like under a reporting rate of 1 second, 10 seconds, and 30 seconds. As you could imagine, it degrades quite noticeably from 10 seconds to 30 seconds. And this is what our vehicles are currently using, the one with the 30-second gap. And this is what we are requiring, the 10-second gap. Another challenge is closed systems because currently, as I said, we do have something like this already. The data is already being gathered, but they are under closed systems. You could not create customized applications out of that data. Actually, nobody could create applications out of that data. Only the LTFRB can currently. And finally, we have number three. I think a big challenge would be when our administrators treat digital systems or infrastructures like physical infrastructure, okay, because it's different. So takeaways from this presentation, okay? There is value in data, but for us to be able to extract that value, we need infrastructure, we need systems. The value and data can help defray the costs of modernization. It could help lead to more efficient public transportation systems. However, as I said, if we are going to succeed in value extraction, we need to make sure that we have devices, standards, and infrastructure that are fit for use and that are future proof. Thank you very much.